Linear programming is a technique which is used for decision making under certainty. In this method, a desired benefit, such as profit, can be expressed as a mathematical function of the value model or objective function of several variables. The solution is the set of values for the independent variables, such as decision variables, that serves to maximize the benefits, or you can say in many problems to minimize the cost, right, subject to certain limits such as constraints. So a linear programming model seeks to maximize or minimize a linear function subject to set of constraints. Constraints are not in our control, and we have to um, whatever constraints are given in the problem, we have to take care of that. Otherwise, it will not give me correct solution. Steps include, first of all, I need to state my problem. Second would be, what are the decision variables or the independent variables. Third would be objective function or value model. And fourth, I need to state my constraints. The importance of linear programming, well, many real world programs lend themselves to linear programming models, and many real world problems can be approximated by linear models. To date, linear model programming has been used to different applications and research areas of manufacturing, marketing, finance, advertising, agriculture. So here we have a very simple problem. We have a factory and it's producing two products, product X and Y. Product X is giving $10 profit per unit. However, product Y is producing $14 per unit. So what is the production level of X units of product capital X and units of product Y that will maximize profit P, represented by P here, each day? So let's see, if there are no constraints, one would say just produce product Y, no need to produce product X, because product Y is giving me more profit. However, sometimes, or to be like in real life, your project or your day-to-day operations are subjected or to many constraints, such as, will you be able to sell um, that much of product, right? Other constraint could be, do I have enough raw material resources available, do I have the required manpower available? So there are constraints in real life, right? In this problem we have constraints also. So here we have 5 workers, 3 machinists and 2 assemblers. and each work only 40 days a week. This means that we have 120 hours for machining process and we have 80 hours for assembly process. Okay, so here they are saying that product X requires 3 hours of machining and 1 hour of assembly per unit. Product Y requires 2 hours of machining and 2 hours of assembly per unit. Okay, so state the problem. What I need to do first here is to write maximize P, and that would be P is equal to 10x plus 14y. X is the number of product capital X to produce per day, and small y is equal to number of product capital Y to produce per day. So this is basically my objective function. P is equal to 10x plus 14y. Let's talk about constraints. 3x, 3 hours of machining, plus 2y of machining for y, so 2y here, 2 hours, and I have only 120 machining hours because 3 machinists, so 3x plus 2y is less than or equal to 120. Second constraint is about the assembly hours, so x here, x plus 2y here is the assembly unit, it should be equal or less than 80 hours of assembly. Here we have one more constraint also, and that is small x and small y that are always positive, that cannot be negative. So that's a very important constraint to remember. Okay, first of all, let's say